Section 2.5, y equal mod fx graph and y equal f mod x graph. Let's say temperature 2, 3, minus 4, minus 5, minus 8. So this is a few readings for temperature. And when we put mod value, this all numbers, if it is positive, stay the same, and if it is negative, become positive. So that is the mod function. Turn everything positive, leave as it is, and negative turn into positive. Now, here I said this is temperature. Likewise, now this is mod. It means turn into positive. What? Y. In here, it tells that all the y values we need to turn into positive. So whatever the fx value, make it positive. When we draw a graph like that, so everywhere we have coordinates, x value and y value. So here y value is positive. If you select any place somewhere here, I'm looking for y value is positive. And if we look at this point, so y value is negative. So in this point, y value is negative. This point, y value is negative y value. I'm not interested in x values because the command is given make all y positive. Now this is y equal fx graph. Now and okay, when we look at this point, so this is positive. So we can see that in these points, any point here, all y values are negative. Now, how can we draw y equal mod fx graph? It means, okay, when you look at this one, this point, okay, it is positive. So leave as it is. Leave as it is. This point, the y value positive, leave as it is. This point, positive, leave as it is. This point is negative. Then negative we want to turn into positive. In that case, okay, let's say this x value is okay, we'll leave as it is empty. Guys, so x value, so this distance same as this distance, so we measure. And now assume this is a, then this is going to be a, let's say minus b, this one, now it is plus b. Now instead of this point, now the mod graph, this is the point. Another one, this is x value, let's say x equal alpha, so this is alpha minus c, this height is c. So now I want to make this minus c to positive, so same height c and here, so this is alpha c. Likewise, this each and every point we want to bring into this side. Then you will see a graph like this. And I'm talking about y equal mod fx. So we turn all the negative y's into positive. Basically, so this is y equal fx graph, right? So positive leave as it is, And negative part, if you bring a mirror here, so the mirror reflection. So that is the easiest way to draw. So all negative y values I made into positive y value. Another graph. Y equal fx. Now I want to draw y equal mod fx. So what is the command given? All y value has to be positive. Now when you look at in this graph, if you select this point, it is above the x-axis, positive, and this point above. So any graph, any part above this one is positive. All y values here positives. So this is fine. Now we look at that part is fine. X, Y. Now I want to turn this one into positive, because if you look take any point, the y value is negative. Y value is negative. So I want to turn into positive. So this point is as it is, and let's say this point. So x value is stay the same, and this height is, let's say, alpha height. Then I want to measure the same height, alpha. So then this point is alpha. So somewhere here, alpha. Um, this is minus alpha, and x value I will take a minus alpha, now a plus alpha. So it is here a plus alpha. So earlier this point here, now I bring into this level. So likewise this one. So mirror reflection. When we give a mirror, when we keep a mirror, so this point I can see in here, and this point I can see is here. So basically this is the graph, mod graph. So this is the graph. So we have to turn this negative y values to positive. To do this one, we want to bring a mirror, and we want to consider the view and keep on this x-axis or mirror reflection, uh, and we can easily complete. Y equal if mod x. So what will happen when y equal f mod x? Let's consider y equal x plus 2 graph, this kind of graph. Let's consider two values, x equal minus 1, then y equal minus 1 plus 2 plus 1, and x equal 1, 1 plus 2, y equal 3, and then y equal mod x plus 2. Then what will happen when x equal minus 1? What is the answer? Minus 1 plus 2 minus 1 mod plus 2, which is 1 plus 2 is 3. Y value is 3. And x equal 1. Again 1 plus 2, which is 3. Now, what is the observation? For x equal minus 1 and x equal 1, there are possibly two different values. But when here x equal minus 1 and x equal 1, you will get the same y value or same height. Now here when x equal 1, this height is 3. This is x equal minus 1. This height is 1. But what will happen with the mod x graph? When x value is 1, yeah, this height is 3. And also x value is minus 1 also, this value is 3. Same height. So this is the point. So this is the height 3. Likewise, when we introduce mod in this way, what we are doing, we are for any x value, if you take x equal alpha and then y equal b, if you take x equal minus alpha, then y is still b. Assume this point is x equal alpha, this height is b. Then when you look at minus alpha, still it is, this height is b. Basically, the graph is going to be like this. So this is the graph of y equal mod x plus 2. So this mod x fix in the y value, the height of the y. So the simple way of drawing this one, if we bring, if we know y equal x plus 2, positive side. So this is the positive side and we don't need negative. This is not the graph, negative graph. Then if we keep a mirror in this y-axis, the mirror reflection. So this is become now y equal mod x plus 2. The example, assume we have a graph like this. This is y equal fx. So I want to draw y equal mod f mod x. So then what I'm going to do, I will leave positive as it is and delete this side. I'll bring a mirror and keep here. Then the mirror reflection, it means if you take this x value, when it is minus a also, you get the same height. It means it's going to be the mirror reflection of y-axis on this part. Another one, assume if we have this graph and this is y equal fx. Now I need y equal mod f mod x. Then what I'm doing, I'm delete this part. I'll bring a mirror, then same as this one. We'll look at example 17 on the book. So this is the example 17 and this is fx is given. We want to draw mod fx and f mod x. So first of all, the graph is you can see like this, and y equal fx. Now I am going to do mod fx. So I will delete, basically I will bring a mirror and keep in this side, and I will take the negative part, negative y values made to positive, and I will delete this one. So now this is the mod fx. Now I draw the graph again. X y equal fx. Now I need y equal f mod x. Then what I am going to do, I will leave this part, and I'll keep a mirror here, and I'll draw the mirror reflection of this. So this is y equal mod fx, y equal f mod x. This value is -2 and this value is 5. And for example, if the domain, restricted domain, -3 x greater than 6, like this, then this is 3, and graph you can't go more than that, and this is 6, so graph is limited. So this is 6. So this is the graph if the domain is restricted. Example 18. Gx is given sin x graph, domain restricted -362, positive 360. Then we know that this graph, sine graph, always go with 0 0. This is 180 and another 180, and the range is -1 to +1. So this is the graph. Y gx equals sin x. Now we want to turn to gx y equal mod gx. It means all these negatives to make to positive. So in that case, if we bring a mirror here, and if we keep from the other side, then this part is become like this. And here also I have y negative values, so uh, it's going to be something like this. If we keep the mirror, then this will become like this, and this is y equal mod gx. And again, y equal g modulus x. So this is the sine graph, -362, positive 360. And now I need this one. What I'm going to do, I will delete this one, and I'll keep bring a mirror here, and I will leave. Then this part is going to be same. this part. So this is the mirror on y-axis. This is the y equal mod sin x, and this is y equal sin mod x. Example 19, y is equal hx is given, so we want to draw y equal mod hx. Then we want to look at where the y negatives. So y negatives here. So we want to turn these y negatives. If you look at this point, y value negative. If you look at this point, y value negative. If you look at this point, y value is negative. Then you want to turn all this negative value to positive. So bring a mirror and leave it here. Bring a mirror and leave it here. So this part is going to be something like this. This height is this. So we have to delete this one. And this bit again negative values, so it is going to be positive when we keep a mirror here. So we have to delete this one. So this is mod hx. Now we want to draw y equal h mod x. H mod x. Then I will delete this one to go back to the previous one. It's like this, and the graph was like this. Now what we have to do, we have to delete this part left side and bring a mirror and leave it here and draw a similar graph to this side. If this is 3, this is also going to be 3, and something like this. So graph is like this. Then the mirror here, the same way. Mirror reflection. As a summary, if we have a graph y equal fx, something like this, so what will happen if it is y equal mod fx? Then all this side will go to the other side, and you will get a graph circle something like this, and this is the mirror reflection on this one, something like this. And we have to delete that graph. And the other one is if the graph is this one and y equal f mod x, so the graph is going to be, we delete this side and the mirror reflection as it is. If this is b, this is b, and if this is a, this is k, then this is k, and this is l, then this is l. Mirror reflection. I redraw this one. So this is mod fx, something like this. and this is y equal f mod x, so the reflection of this one. So the same thing the other side. A, A, B, B, C, C, D, D, E, E, F, F. We'll discuss exercise 2E now in the next section.